Welcome to lesson 116. Today we're going to be practicing giving fractions a common denominator. Now let's recall that when we multiply a fraction by a fraction named for 1, we are always going to get an equivalent fraction. Here we have 1/2 times 2 over 2, which is a name for 1, equals 2/4. 1/2 and 2/4 are equal fractions, they just have different numbers. Now, when we have a fraction that we want to give a new denominator, we need to figure out what to multiply by to get to our new denominator. So here we have 2/3, and we want this fraction to have a denominator of 9. Now, it's starting with a denominator of 3, so we're going to multiply 3 times 3, because 3 times 3 is 9. That means that we need to multiply the top by the same number, and 2 times 3 is 6. So 2/3 and 6/9 are equivalent fractions. Here we have 4/9, and we want to give this fraction a new denominator of 36. Now 9 fits into 36 4 times. So I'm going to multiply the bottom by 4, which means I must also multiply the top by 4. 4 times 4 is 16, which means 4/9 and 16 over 36 are equivalent fractions. Here we have 5/8, and we want it to have a new denominator of 72. Now 8 fits into 72 9 times, which means I'm going to multiply the bottom and the top by 9. And 5 times 9 is 45. Here I have the reverse. I already have a new numerator. So to figure out the denominator, I need to think how many times does 6 fit into 54? And I know that's 9 times. So I'm going to multiply the top and the bottom by 9, and 7 times 9 is 63. Here I have 7/8, and I want it to have a new numerator of 21. 7 fits into 21 3 times, which means I also need to multiply the bottom by 3, and 8 times 3 is 24. And here we have 1/8 becomes something with 7 in the numerator. 1 fits into 7 7 times, and that means I'm going to multiply the bottom by 7, and 8 times 7 I know is 56. Now we did all of that because we're going to be talking today about fractions that have different denominators. Now just like you can't add 5 apples and 6 oranges and get 11 apple oranges, we can't add 3/4 plus 4/5 because they do not have the same denominator. Here I have a 5 and here I have a 4. We know that when we're adding, we're supposed to leave the denominator alone, and so, well, when we have different denominators, we can't add them. We have to change the fractions first. Now, normally when we have the same denominator, everything's good. We can do 2 plus 7 is 9, and we keep this denominator the same. And here we can do 2 plus 1 is 3, and we keep the denominator the same, and 3/3 we know equals 1. But here, we do not have common denominators. That means that I have to do something first before I can add them. I either need to turn them into all apples or all oranges, or maybe something new like a lime. Now, when we are adding and subtracting with fractions that have different denominators, we have to give them a common denominator. That means they both need to be the same on the bottom. To do that, we have to figure out what do these fractions have in common. Well, 5 and 4 are different numbers, but what do they have in common? I need to think of a number that they have in common. So the first way to figure that out is first I can check, do the denominators fit inside of each other perfectly? So for example, does 4 fit into 5 perfectly? And I know the answer to that is no. And does 5 fit into 4 perfectly? No. So I can't do anything with them yet. I am going to move on to step number 2, which is I'm just going to multiply the denominators by each other. So I'm going to multiply the 4 times 5, and I'm going to multiply the 5 times 4. Now, just like we practiced before, whatever you do on the bottom, you have to do on the top. So here I'm going to put a 4, and up here I'm going to put a 5. Then I'm going to multiply across. 3 times 5 is 15, and 4 times 5 is 20. And down here, 4 times 4 is 16, and 5 times 4 is 20. And we finally reached our goal. They now both have a common denominator, which means I can either add these together or I could subtract them, and I would be able to do it. So here we have 1/2 and 2/5. We want to turn this into two fractions that have a common denominator. So first question is, does 2 fit into 5 perfectly? I know no. So I need to multiply them by each other. So I'm going to multiply them by opposites. I'm going to multiply the 2 times 5, and I'm going to multiply the 5 times 2. And whatever I do on the bottom, I have to do on the top. So here I'm going to get 5 times 1 is 5, and 2 times 5 is 10. And down here I'm going to get 2 times 2 is 4, and 5 times 2 is 10. And they now have common denominators. That means I could add them or subtract them. Here I have 1/3 and 1/2. Does 3 fit into 2 perfectly? No. And does 2 fit into 3 perfectly? No. So I'm going to multiply them by each other. I'm going to do 3 times 2, and I'm going to do 2 times 3. That means that here I'm going to put a 3 on the top, and here I'm going to put a 2 on the top. And 1 times 3 is 2, and 2 times 3 is 6, and 3 times 1 is 3, and 3 times 2 is 6. Now, in this fraction set, we have 2/3 and 1/6. Now, my first step is to always ask, do the denominators fit together? Well, 3 actually does fit into 6 perfectly, and it fits into 6 perfectly 2 times. So I'm going to multiply my top fraction by 2/2. Now, 2 times 2 is 4, and 3 times 2 is 6. And look at that. Without doing anything to my second fraction, they now have a common denominator of 6. Here I have 1/8 and 1/3, and it's asking me to rename these fractions to have a common denominator of 24. Now to get to 24, I have to multiply 8 times 3. So for this fraction, I'll multiply 3/3 and get 3/24. And for my bottom fraction, I have to multiply 3 times 8 to get to 24. So I'll multiply this one by 8/8, and 8 times 1 is 8, and 8 times 3 is 24. Here I have 1/5 and 1/10. Does 5 fit into 10 perfectly? Yes, it does. It fits into 10 perfectly 2 times, which means I'm going to multiply the bottom and the top by 2. 1 times 2 is 2. 5 times 2 is 10. And just like that, I have common denominators without changing the bottom fraction. And that is lesson 116, and how we give fractions common denominators.